Hello there, ladies and gentlemen. A very warm welcome from all of us here at Analog Devices. My name is Carissa Seat, and I'm pleased to be your MC and moderator for today's Analog Devices EagleEye webinar. Now, we do value your time, and we hope that today's webinar will allow you to glean as much information and also to get your questions answered through a live Q&A with our speakers. But first, please allow me to acknowledge the many partners who've made today's webinar possible. I'll first like to give special thanks to Excel Point for providing us with the space for this webinar to come to you live from Planet Spark during this very challenging time with the extension of COVID restrictions. I also like to acknowledge and to thank our co-sponsors in no particular order. We have Analog World Co. Limited, Anstack, Arrow, Excel Point, Magnica Sci-Tech, Morihan, Mauser Electronics, and Shinbang. Now, for those of you who might know a little bit about Analog Devices, a bit of background for you, we are the world leader in the design, manufacture, and marketing of a broad portfolio of high-performance analog, mixed-signal, and digital signal processing integrated circuits that is used in virtually all types of electronic equipment. Now, we focus on key strategic markets where our signal processing technology is often a critical differentiator in our customers' products, namely the industrial, automotive, communications, and consumer markets. Now, we currently produce a wide range of innovative products that are designed to meet the needs of a very broad base of customers. Now, in this webcast today, we will provide an overview of the complete range of EagleEye people counting, hardware and software solutions provided by Analog Devices. Now, we hope that you'll walk away with a deeper understanding of the development and the applications for people counting usage. Now, the people counting system allows easy integration so that you can solve high complexity customer problems within your existing models. Now, ADI offers hardware and software technology building blocks, allowing customers without optical or camera experience to go from evaluation to production in a rapid fashion. In this coming up segment, we will have two presenters who will be sharing more about this solution. Our first is Colm Slattery. He is the Strategic Marketing Manager for ADI in the Industrial Systems Group based in Limerick, Ireland. He joined Analog in 1998, and he has held multiple roles, including test development, product, and system applications. Now, Colm runs the EagleEye platform business and commercial strategy. Now, our second presenter is Alessandro Vinco. He is a systems application engineer for ADI in the Industrial Systems Group. Born and raised in Italy, his background spans across several wireless systems and technologies for smart buildings and environmental sensors, power management, and electrical communications. So with that, ladies and gentlemen, let's turn our attention and watch the presentations.
Okay, I'll get started. So hello, everybody. My name is Colm Slattery. I'm a marketing engineer in our industrial business unit. I'm located in Limerick in Ireland. And together with my colleague Alessandro, we're going to give you an update on the ADI EagleEye platform. So EagleEye is a system-based solution for people counting. It's primarily targeted at space and energy management in buildings, but it can definitely be leveraged into many other market and application areas. I'll talk a little bit more about that in a couple of slides from now. I guess one pointed comment or clarification, through the EagleEye platform, ADI we're not proposing or we're not trying to sell a complete camera-based product. So that's one important point of clarification, I guess. The EagleEye platform is aimed to provide a set of technology building blocks, our technology components, so hardware components, software components, that really enable our customer to develop their own people counting system-based solution, add their own connectivity to it, and design on our technology building blocks. So we've already done the development, so very low risk, and enable our customers to get to market quickly. So I think that's a key value proposition of the EagleEye technology, and I know Alessandro will be talking a little bit more about that later in the presentation. So what are some of the, I guess, the trends around buildings that are driving the need for EagleEye based technology? And I guess a couple are, the first one is 25% of the world's CO2 emissions actually comes from powering buildings. So a very significant amount of CO2 emissions, of which 2/3 of those emissions come from lighting control systems and heating control systems. So that's a very significant data point about energy usage and consumption around buildings. The second, I guess, trend is the whole strive to improve the quality and the work experience of people and making buildings more healthy for people as they spend so much time indoors and in meeting rooms. So improving air quality is going to become an even more critical factor in work environments going forward. So having a technology like EagleEye, which provides a lot of, I guess, data analytics and data insights in terms of space occupancy and space management to building providers and building management systems, can really help improve both not only the efficiency of running a building, but improve the sustainability of running a building, and it can also make buildings more healthy. So a very strong, I guess, value proposition around the EagleEye technology. So beyond just buildings and commercial buildings, the whole area of kind of retail space management, so understanding, where people are in retail spaces, where they've spent their time, developing heat maps. We can use the EagleEye technology to give all of these insights beyond just traditional buildings, so into the areas of retail, into cafes and restaurants, so within the zones of cafes and restaurants, where are people sitting, which areas are free, which areas are full, into cinemas and theatres. So for example, from a safety use case, how many people are in a cinema, a theatre or a lecture hall, or from a fire safety perspective, we can repurpose and re-leverage the EagleEye technology to support all of these different market and application use cases. And the last slide, I guess, before I hand over to Alessandro is, what are the key I mentioned on the first slide, the technology building blocks that we offer as the key value proposition. So again, for EagleEye, we're not selling a camera, we're selling a set of technology building blocks. And the key two building blocks we're selling is a proprietary algorithm. So an executable algorithm that can do people count, in these targeted use cases that I talked about, in combination with running that algorithm on an ADI low power computer vision DSP. So it's one of our Blackfin family of devices. So it's the ADSP BF707. So those are the two key building blocks that make up the EagleEye platform. And with these two, I guess, key technology building blocks, we can enable customers either to develop their own camera-based solutions or develop their own camera-based solutions and full sensor to cloud systems. So it's a very flexible solution depending on what the end customer's requirements and use cases are. So I'll hand over to Alessandro now to go into the technology around the EagleEye platform in a lot more detail, and hopefully give you some ideas about how you would get to market using this platform for your targeted application use case. So over to you, Alessandro.
All right, so let's take a look at the ADSW4000, which is the first ADI people counting algorithm. So in this case, the ADSW4000 can cover, as you can see here in the image, two main use cases. One is a single sensor configuration, and the second one is a multi-sensor configuration. So in the case of single sensor configuration, the sensor is mounted, as you can see here, it's the white box in the middle of the space. It's mounted on the ceiling, and it provides a count of people and their location within the room. So what we call the location mapping. The coordinates and the number of people are transmitted by the sensor in the form of text. so there is no images being recorded or stored on the device. And of course, no personal data is collected about the occupants, only their number and their coordinates. And this is the only data that the sensor sends out. In the case of single sensor, of course, this is used for smaller spaces, and the sensor is mounted, as I said, in the middle of the space, just to maximize the coverage area. It's mounted on the ceiling, so looking down on the space to monitor. On the right-hand side, instead, we see a typical example of spaces where we need a higher coverage, a wider coverage of wider areas. So we use multiple sensors in this case. We call it multi-sensor aggregation. And in this case, we can use several sensors and capture data from each sensor that can be later be aggregated on the customer end. So this, of course, allows to keep the same level of accuracy of a single sensor, but on a much wider area. The key points of our solutions are that, for example, by providing you with the hardware and software reference design and building blocks, customers can design their own people counting solution with a specific hardware and software adjusted to their solution indeed. So this is the first key point. There is no need to buy expensive off-the-shelf cameras. You can just design your own camera using the building blocks and the reference design that ADI provides. Of course, this allows customers to save more than 70% compared to buying an off-the-shelf camera product. So by giving you the building blocks and the reference design and all the design references, you can design a custom camera that can be adapted to any mechanical design, any layout, in order to provide you with the full flexibility. And in turn, obviously, you will also own all the data that comes from the device. There is no need to share your data with any third party. So by taking the DSP subsystem, so the EagleEye reference design, you can integrate it into hardware and software that is already available, for example, for a customer, and you can go to the market with a full developed system. This will provide a very quick path to market, so very quickly you'll be able to take our building blocks, design your own camera with people counting capabilities, and go to market. There are a few different types of applications that we can think for the EagleEye, and there's 3 or 4 main types of customers that we envisage with our solution. The first application, the first type of customers are sensors integrators. So these are people that use the EagleEye device, for example, to enable smart lighting control. So, for example, in this case, we have customers that enable their lights depending on the number of people and the location of people passing through the sensor. Or we have other customers instead that develop sensor fusion devices, which can be environmental sensors with added functionality, for example, people counting, or air quality sensors that are used in offices and that add the people counting capability to better control the HVAC or the lighting and so forth. So these are the 2 main types of sensor integrators that use EagleEye as a people counting solution in existing devices. But of course, you can also develop your people counting camera. This is another type of product that we enable with the EagleEye reference design. And if there is any need for hardware or software expertise, or if there's any need to go to the market faster, we also provide turnkey solutions with hardware partners. So we can develop very quickly a new people counting camera using the reference design at one of our partners. I'm just going to talk briefly about the Triakit, which is our development platform that we've developed in analog devices for the evaluation of the ADSW4000 people counting algorithm. The Triakit device is the sensor itself, which is shown here in the picture. And this is basically a similar device to a smoke detector. It has obviously the vision sensing module mounted in the middle, looking out of the sensor. It has a microcontroller and it's USB powered, so it provides a very easy interface to power up and configure. This is mounted, as I said, on the ceiling and looking down in the region of interest. And it comes with a 1-year algorithm license included. Together with the sensor, for a full sensor to cloud evaluation platform, we provide also access to the ADI EagleEye Cloud. On the ADI EagleEye Cloud, we provide access to an online dashboard where the sensor will upload the data for easy evaluation. So on the dashboard, the customer will be able to check real-time and historical data coming from the sensor, and it will have they will have access also to all insights, actionable insights that we make available to customers, such as the percentage of time the space is occupied, for how many hours, for example, and which hours are busier for that specific space, and so forth. And this also is included for 1 year in the price of the trial kit. To configure the sensor instead, once it's installed, we have a Bluetooth interface inside the sensor that allows an easy commissioning using a tablet app. This tablet app is available for iOS and Android tablets, and it will allow for an easy and quick commissioning of the sensor once it is installed. We also provide a PC tool that works off the USB connection, and in this case, it's not normally recommended, but it's just for advanced troubleshooting and manual configuration of the sensor. It can be used instead of the mobile app, but it's normally just for advanced users. So just to keep an eye on the tablet app, this is a short animation showing how the app works. So the sensor is connected via Bluetooth with this app, and by taking one snapshot of the room, that will be, by the way, discarded afterwards, the sensor can be commissioned. For example, in this case, we can detect people in a specified area. So we can tell the sensor, count people and tell me the coordinates of people in this area specifically and not other areas. So this makes the sensor a lot smarter for the person detection. And from here, the customer will also be able to connect the sensor to the Wi-Fi for the upload of data to the cloud and set up a few other parameters for the sensor. After the sensor is commissioned, instead, the customer will have access to the cloud dashboard, and the customer will be able to check the data that is sent up to the cloud from the sensor. Will have the time and the number of people for each individual time of the day. We will see the most common areas where people are sitting or standing. We'll have a few additional historical utilization trends shown, and so forth. So by looking at the data, the customer will have immediately an idea of how the spaces are utilized and all the enablements that the EagleEye system can provide to customers, in the sense of being a full system solution for people counting and usage of the spaces. So what are the steps to go to market with EagleEye? So we designed the EagleEye system to be let's say, a reference design for our customers. And to go to quickly market these devices, we wanted to make sure that customers have a very specific building block that they can use in their products to make new devices in very, very short amounts of time. So this is the main architecture of the device. This is the core technology, the ADI technology, which comprises of the ADSW4000 algorithm running on the ADSP Blackfin 707 digital signal processor, together with some power management parts. Of course, we need also the vision sensing module. This is a third-party module that we have available, and it comes obviously with optics and the system on chip for imaging included. So this composes the 2D vision sensing part, let's say. but then we need a couple of other extra components, so for the flash memory and LPDDR, which are also required for the reference design. And these all together compose the EagleEye camera system. To connect the camera system to the customer microcontroller or to the customer system, we only need a Uart port, and the Uart port will be used to communicate with the camera system, send commands back and forth that can communicate then and be integrated into the customer's design. So whatever platform or microcontroller or GPU the customer has, this can be used together with the ADI EagleEye camera system just by adding a Uart port. So how do we actually go to market then? The first suggested step for a customer is to buy the camera module. This is the first part of our reference design, and this is required for the correct functioning of our EagleEye system. The second step is to purchase all the analog devices parts. So we have the Blackfin DSP, the ADSW4000, which is our software algorithm, and then the 4 power parts that I've listed in the previous slide and are also reported here. Once all the components are available, of course, the customer can work on integrating into a camera housing or an existing product to get to the final solution. So to actually build the EagleEye system, we provide all the hardware design files and the bill of materials. So we provide indeed all the schematics, so customers can redesign their own boards based on this schematic. We provide all the board layout files for easy integration and modification of the layout of the board. And of course, we provide the bill of materials. The bill of materials will also, of course, include not only the analog devices parts and the vision sensing module, but also the flash, which is a required part, as I said, for the correct functioning of the system. How do you actually get the ADSW4000 algorithm? So the algorithm is provided by ADI upon purchase of a software license as a securely signed binary. So this is shared by ADI in the form of an encrypted and signed binary. So what we suggest is to get a pre-programmed ISSI flash chip that has already burnt in the algorithm for a simple plug-and-play solution. ADI provides the ADSW4000, as I said, as a signed and encrypted binary to the customer for security reasons, of course. So we know that each EagleEye device is protected from external attacks, from IP, let's say, from an IP perspective as well. We provide all those security aspects. Customers can contact the local channel partner or distributions, of course, to discuss pricing and quantities with ISSI. Although once the customer is provided with the signed and encrypted binary, there are also several other small partners that can allow for pre-programming of the flash with this binary. There are also 2 licensing options available for the people count software. One is a perpetual license with no need to reactivate on each device after the software expires. So this is normally the preferred solution, because once you get your devices, you load the license onto them, and it's a perpetual license, so there is no need to upgrade the software any longer, and you pay for it only once. But we also make available a yearly license, so this can be renewed each year with a new license request. So how do we connect EagleEye to a custom MCU platform? So for example, to an existing device. As I said earlier, there might be several MCU or sensor systems already existing at our customers, which can feature, for example, MCUs, different operating systems, additional sensors. So what we recommend, as I said earlier, is in the case, for example, where we have several cloud applications, full systems already available, all we need to do is add a Uart port. So a Uart is all we need to do to communicate with the DSP subsystem from EagleEye. In this case, a serial interface is a simple 2-wire Uart port at 3.3 volts, so this is all that is required to communicate with the EagleEye DSP subsystem. Of course, after that we'll have to take care of the commissioning, which, as I said, can happen through a wired or wireless interface. So how do we communicate with the EagleEye DSP subsystem? We saw that commands are sent over UART to the device. So how do we communicate? What are these commands? What do they look like? So these commands are a set of commands that ADI makes available to customers. It's a set of APIs to communicate with the black box that is the EagleEye DSP subsystem. So in this case, the UART commands can be used to set communication parameters with the EagleEye system, to set commissioning masks, for example, when we're installing the device, or also to run over-the-air updates. So if you have, for example, a cloud infrastructure where we can share the algorithm updates, of course, over-the-air updates can be performed using UART commands. These, again, work between the DSP subsystem and a customer MCU by using UART. We have a specific set of commands with message and response layers, and of course this will be made available to the customer as part of the reference design. So we have a full user guide available. And what does the metadata look like? So once we get data from the sensor, this is the format. So the format is a JSON packet sent over UART in push mode by default, at a user-defined rate with a minimum packet rate of 200 milliseconds. So we can get a new measurement at this rate, or any higher rate, of course, that is configurable by the user. The data is sent in JSON format, and here we can see a general packet format. So in the packet, you can see there will be the packet number, there will be the count of people, and some other properties and, let's say, variables, including the people ID, so the number that identifies each person with a specific set of coordinates, just to understand where people are in the room. In terms of algorithm performance, this is what we can see. So we recommend an installation height of 2.4 to 3.6 meters, which correspond to 8 to 12 feet for maximum accuracy. This is how the accuracy is computed. I leave here the equation, but to give a summary of the accuracy we can achieve with the EagleEye sensor, this is 90% plus in a 3-meter radius room, which corresponds to about 18 square meters, or 14 by 14 feet. And the accuracy drops slightly, but we can cover up to 5-meter radius rooms, so about 50 square meters, with a single sensor, with the efficiency dropping only to 80% in most cases, or higher. Of course, if we put multi-sensors, we can achieve much higher accuracies, even at 50 square meters of coverage. We have a few frequently asked questions by our customers, and so I wanted to address some of them here. So the first question that we normally get asked is, what is the maximum number of people that the sensor can detect? And this is 24. So a maximum of 24 people can be detected per sensor. Of course, if we have spaces that normally have more than 24 people, because they're much bigger, for example, than a standard room, we can use multiple devices, as discussed in the previous slides. So in this case, obviously, we'll be able to get 24 people per sensor, and 48 with 2 sensors, and so on. Does it work with high-density places? So what we recommend, there is no specific limit, but let's say we suggest for maximum accuracy that people are at least 0.5 meters apart. So in this case, the algorithm works at its best performance. Can the user specify multiple areas in the same space? So yes, we can divide the available space in 6 sub areas. So we can have up to 6 areas where we have an individual count of people. For example, if you think of an hotel lobby space, we can count people, for example, with a single sensor up to 50 square meters, as I said, and these 50 square meters can be divided in up to 6 areas. For example, the entrance, for example, the counter of the hotel lobby, or, for example, the lift area. So we can count people individually and have data and, let's say, occupancy scores for the different areas within the same sensor. Is the Triakit battery powered? No, because the algorithms require quite significant computational power, which is not compatible with battery operation. The power consumption is about 1.5 watts, so a battery would not last for long in these conditions. However, our reference design is compatible with a wide input range of voltages, so we can use voltages ranging from 5.5 volts to 36 volts DC. So this includes, of course, USB powered devices, but also 24 volts, which is quite common in domotics and let's say, intelligent buildings. Can the ADSW4000 detect other objects like cars, boxes, etc.? No. So this is a people counting device, and it's specifically designed and optimized to count, detect, and let's say, provide data about people only. There are more FAQs once customers register to the EagleEye space, and these will be available at peoplecountfaqs.analogcloud.io. So how do customers get started with EagleEye, or potential customers? Well, there's a few resources available online, but in general, the first thing that I recommend is to visit the EagleEye landing page. Here, there's all the people counting technology. It's explained very well how these are, all the information is available here, what use cases we cover, what applications we target, where EagleEye is a good fit. So this is the perfect place to start finding out more about EagleEye and people counting technologies. We can order a trial kit, of course, on analog.com or at channel partners. So here you will get your device, and of course you will get access to the ADI cloud, and some credentials will be created for you for the download and access to both the analog device's dashboard and the tablet app for commissioning of the device. Next, you will, of course, receive and activate your trial kit on analog.com to get access to your dashboard. And a new EagleEye Cloud account will be activated to access both, as I said, the online dashboard and also the tablet app. Available resources on analog.com are, of course, the EagleEye landing page that I just mentioned, and there's an ADSW4000 product page where you can find out more about the people count algorithm. There's also the Blackfin DSP 707 product page, and of course the trial kit product page as well, where you can find out more about the trial kit, the design, the pricing, and so forth. Any licensing or support request can come in at eagleeye.support@analog.com, so you can simply send an email for more information. And we also have an engineering zone area specifically being developed, so it will be available soon. Before we close, just a quick look at what's next. So we have a flow count algorithm also becoming available shortly. This will run on the same hardware of the ADSW4000, and it's instead designed to count people flowing in and out of a virtual threshold. So this can be used as a door count. In this case, this is very powerful to count a higher number of people accessing crowded places like shopping malls, stadiums, cinemas. So there is no need in this case to cover each individual square meter of floor with multiple sensors. We can just use one or more sensors only at the entrances to understand how many people are flowing in and out of the space. There are samples already available, and as I said, this will be an easy and quick way of evaluating how many people are flowing in and out of a space and have an immediate count. The device, as I said, runs on the same EagleEye hardware reference design, so there is no need to change the hardware design. The flow count device covers doors with up to 3 meters in width with a single sensor. So even big entrances for shops, for example, can be easily covered by this algorithm and this device. And we provide a high frame rate, 9 frames per second, and low latency of 110 milliseconds approximately. So within a second, we can get up to 10 measurements of the people flowing through the threshold. It's 90% plus accurate, so we get quite a very good accuracy for the 2D technology, even when compared to other technologies such as brake beam or infrared. We're very high accuracy at a much lower price point. Of course, there is no limit to the number of counted people. So in the people count, in the standard people count algorithm, we can count up to 24 people with one sensor. But in this case, since we're only counting people flowing in and out of the threshold, there is no limit to the number of people we can count. And we also provide a similar experience of the people count Triakit. As you can see here, we have a full cloud development platform, cloud evaluation platform, where you can get a real-time count of people in the space that you are monitoring with your Triakit, and we can get very interesting statistics and historical trends as well. So this is again the flow count algorithm for counting people at doors, at entrances, and this will also be available for sampling upon request. This concludes my presentation of the EagleEye. Thank you, Colm, as well for your introduction, and we'll be happy to take any support requests at eagleeye.support@analog.com or any questions you may have. Thank you very much.
Thank you very much, Alessandro and Colm, for taking us through the presentation, giving us an in-depth idea on this solution. But I'm sure along the way, many of you might have some questions that are coming up in the course of your listening and, of course, thinking about the work and where you'd like to apply these solutions. So we are going to be opening this time to a live Q&A, and I thank you to those who have already submitted your questions. You can continue to keep them coming in through the Zoom. So at this point, I'd like to invite back our two speakers to join me on screen. We have Colm and Alessandro. Hello, gentlemen.
Hi, guys. So I guess I'll start. My name is Colm, as I mentioned in the webinar. I have ownership of the industrial commercial responsibility for EagleEye. So thanks for joining the webinar today. We're very happy to, myself and Alessandro, to introduce the EagleEye technology platform to you. We hope the webinar was useful. And I guess we're open to take questions now. So nice to meet you.
Thank you, Colm. And how about you? Over to you, Alessandro.
Yeah, thank you very much, Charissa, for the introduction. Thank you very much, all of you, for attending this webinar. I'm just happy to answer any questions, and more on the technical side. I'm the system applications engineer, as you saw in the presentation earlier. So any technical questions, any questions on the hardware, the software side, I can answer them. So can't wait for your inputs and to give you my information as well.
Got it. Okay, gentlemen, thank you. The floodgates are now open for questions. And the very first one coming up. I'd like to ask you, does EagleEye algorithm achieve human flow counting besides static counting? Any one of you can take this question.
Yeah, so as I said in the latest slides, we have two different algorithms. The first is people count, the one we discussed today. But of course, on the same hardware, we can actually run a flow counting algorithm. This is a different software product, of course, but it runs on the same device, on the same hardware, and it provides, instead of the static counting, it provides the number of people flowing through a virtual threshold. And this can be, of course, a door, an entrance, a corridor, So it provides statistics in that sense, yes. And this will be available shortly for sampling, so please do inquire if you're interested in that.
Got it. Thank you for that input, Alessandro. Now, the next question that came up is, is EagleEye capable of distinguishing between human and other moving objects, such as vehicles or animals?
Yeah, same thing here. I would say refer to the website for better information and to understand better how to detect people. But let's say the EagleEye solution is a people counting solution, so there is no currently no way of detecting any other objects or animals. However, the people counting algorithm can distinguish between people and animals, for example. So if you have an animal flowing through the space or occupying the space, this won't be counted. It will only detect people and count people.
Got it. It sounds like a very dynamic technology and solution. Now, the next question that came up is, if a wide-angle camera is used, will the area of coverage become wider or larger?
Technically, yes. So the algorithm, of course, is tuned to work on a very specific camera sensor, which is the one we recommend in our reference design. Nothing is stopping designers to use different technologies, different vision sensing systems. However, we do not provide any accuracy data. In that case, we cannot guarantee that the system will work as well. Our own technology, our own vision camera at the moment covers up to 180 degrees with a fisheye lens. So it's already quite extensive field of view. But of course, we don't limit ourselves to that. We just need to make sure that the performances then are tested with different lenses if they want to be used.
Got it. Thank you. Well, at this juncture, if you're having any challenges and difficulties in terms of what you're currently handling right now and you're thinking that EagleEye could be the solution, please share with us your challenges. Please also share with us your hopes and your wishes for using this technology and solution. Now, the next question that came in was, how fast is the refresh rate of sensor to object that can be achieved?
Yeah, and so in general, we need about 2 to 3 frames to detect a person. And then the measurement is instead, so this means that we work at a maximum speed of 100 milliseconds. So we detect a person within 200-300 milliseconds after the person enters the scene, the field of view of the sensor. And then we can get any subsequent measure every 100 milliseconds. So we have about 9-10 frames per second measurement rate.
Will do. And then we'll move to the next question that has come in. I'll try my best to understand this question. It is UART is communication IF. What kind of data streaming interface between sensor and the host? As you can see on the screen, the question. Anyone can take that.
Yeah, it's a simple UART JSON packet. So there is no specific video stream or there is no multimedia being streamed between the DSP and the MCU over UART. It's simple JSON packets. So we listed a couple of examples in the presentation, but mostly it's just text. So we use a specific set of APIs to communicate between the MCU and the DSP over UART, but there are no images being transmitted between the two. It's just JSON packets. So we use commands and responses in text over UART. That's the protocol we define.
All right. The next question that came in has to do with the sensor accuracy. I'm wondering if you could give us an insight into that. How accurate is that?
Yeah, and again, I'd say for reference, you can just refer to the slides after this webinar. But in general, the maximum accuracy we achieve is over 90% on a 3-meter radius. So if you think of a 3-meter radius, that corresponds to about 20 square meters, and we achieve 90% accuracy or higher in those spaces. The accuracy is a bit lower as you achieve the maximum range of the sensor. So when you're covering 50 square meters with a single sensor, the accuracy is about 80–85%.
Got it. It sounds like there needs to be a process of exploration as much as the figures are there, but people will have to try out the technology and solution to experience it for themselves, yeah?
Correct,
with that,
correct.
Yes. Our next question, let's flash it on the screen so we can all have a look at that. What do you have to say about this question that came in? How about
the operating current of the sensor is about 150 to 100 milliamps. So we're talking about 0.6 watts approximately to 1 watt, and up to 1.5 watts when the algorithm is fully running.
Got it. Thank you, Alessandro. Now, I am going to be pinging a question over in just a while to Colin. Now, the question is, does EagleEye algorithm have limitations on image resolution and FPS, and what is the output latency? Is that a question for Colin?
Sorry, can you repeat the question?
Okay, let's have it on the screen in just a while. Does EagleEye algorithm have limitations on image resolution and FPS, and what is the output latency?
So the sensor itself uses a VGA resolution sensor. So that really depends on the range, then will change the pixels is what, 640 by 480. And as Alessandro said, each frame is 30 frames per second. So that's the maximum that the frame rate that the camera operates. And as Alessandro said, we use 3 frames per second. So the fastest latency we can do is 100 milliseconds for the algorithm operation.
Got it. And thank you, Colin. Now, the next question that also came in was about whether tablet is compulsory for the customer demo, or can it be done using the mobile?
I can take that one. So the tablet app is designed specifically for tablets to have a better screen and to have a better, let's say, interface, a bigger interface for the user to configure the sensor. So we do recommend a tablet. There is also another option, which is the PC tool that we discussed in the slides. But normally the tablet is just the easiest because it's wireless and it has a very nice and easy user interface. No mobile phones are supported really, and this is again because the screen is very often too small to provide a decent interface for the user.
Got it. Yeah, and once again, I'd like to open the conversation to those of you who have had difficulties or challenges with your past projects when EagleEye was not available. So we'd love to hear the real challenges that you're facing so we can answer them and hopefully move you forward in terms of advancing and innovating in what you're currently involved in. At the same time, if some of you have thoughts about how EagleEye can help you in your current and future projects, please also share that with us in the chat. I think that's going to be rich learning for all of us. And at any point, Colin and Alessandro, if you'd like to just chime in on what are the common challenges that you hear from customers, about not having EagleEye and what they hope EagleEye can do for them.
Sure. I think it would be interesting here to discuss a bit, give an overview of the typical applications that we're seeing. I'm sure, Colin, you can share quite a few interesting points of the type of discussions we're having with customers, what they're doing with the device.
Yeah, I think, as Alessandro said, one of the biggest value propositions for EagleEye is the fact that we offer a set of technology building blocks. So it's not, as I mentioned at the start of the presentation, we're actually building a camera and selling a camera. We offer a set of technology building blocks. And that meaning allows us to really differentiate and allow our customers to integrate EagleEye into their own system products. So that's something that no one else on the market does. So, we see EagleEye, as Alessandro went through in his presentation, going into lighting control products, into retail products, into environmental sensors, and so offer a very quick path for customers to develop their own system solution. So I'm very interested to know if there's customers here beyond just camera customers that has those type of requirements that they actually want to integrate into their existing products to develop kind of something maybe like a sensor fusion product or something different. So yeah, I'm very open to understanding our customers' challenges and whether EagleEye is actually solving some of our challenges for our customers.
Yeah, so we still have some time with the FAQ, so please feel free to just chime in on what these two gentlemen have shared, and they're inviting you to share the actual real cases that you are currently experiencing. Now we'll go back to some of the questions that are coming in. Now the next person asked, is EagleEye flexible to develop applications on top of it and take raw signals to do additional image analytics?
Yeah, I can take this one. In general, what we define EagleEye as is a building block for other technologies or other devices, but the EagleEye reference design is like a black box. So we only provide a set of APIs to count people and their locations, but we don't really allow a modification of the algorithm. This is our IP. So we just give a set of APIs to communicate with the sensor, but we don't allow any modification of our reference design. What we can do instead is allow customers to add any sensors or integrate the EagleEye design into any other product that contains other sensors that does any other processing. So that is possible, of course.
All right, thank you. Now, the next question coming in is, do you have confidence factor in determining the object analysis?
I'm not sure I understand. Oh, okay. I think I understand the question. So we know the accuracy in detecting people, which is the 90% plus we discussed earlier. In terms of how accurate or how precise we are at detecting people compared to other objects, we don't have statistics, but we've run an extensive set of tests with other objects in rooms, in different scenarios, in different applications, and verified that our detection rate is very high and our false detection rate is really, really low. So again, this depends on the use case, the environment. So the best thing we recommend normally is to test with the evaluation kit the performances at the customer end. So if customers have specific environments, they can test the EagleEye performance in their specific environments.
Got it. And the next question that has come in is, which frequency band and technology do you recommend to avoid interference?
Yeah, so in general, the EagleEye system works, off a Uart interface. There is no interference as such. There is no, we're not relying specifically on any wireless interface other than, of course, the Triakit. So for the EagleEye itself, there is no problems with interference. For the Triakit, for the evaluation platform where we use Wi-Fi, we use 2.4 gigahertz standard Wi-Fi. And so to avoid interference, you just need to be careful with that spectrum.
All right, thank you. So I wonder, in terms of time, whether we have more questions coming in and whether we have time for FAQ, or we will be wrapping it slowly from here. Yep, so as we do gently close the time off, because we want to respect everybody's time, is that I'd like to invite all of you to continue to feel free to submit in your thoughts, challenges, and even questions that are coming up for you after this webinar. We'll be happy to answer all of that for you. And also, as we close off, I'd like to take this opportunity to say thank you to Colm, and also Colm and Alessandro for coming on. this morning for you and this afternoon for us to join us in this hour of learning and sharing more about the solution. At the same time, for any of the audiences, if more questions or topics that come up and you'd like ADI to cover it in the future, please do drop it into the chat. Or you could also take time to go to our website, www.analog.com, and at the same time, you could also reach out to our respective regional distributors for solutions, or if you have questions, you can also email us at cic.asia@analog.com. Well, in the meantime, as we currently wrap this whole session up, it's been such a pleasure being your MC and moderator. And I'd like to once again thank Colin and Alessandro and all our audience for joining us in this very fruitful learning session together. I'd like to wish you all a great day ahead. Until the next time, please stay safe.